So here we are at the Airbus Shopfloor challenge. So the goal of this challenge is to have teams that drill holes on a representative configuration, like if it was on the aircraft. And then we are assessing those holes and the pattern they've drilled based upon defined rules, like the accuracy of the positioning, the quality of the hole, and we are also using some qualitative criteria to define whether their technical solution makes sense for Airbus or not.
We are Team Bug Eaters. We are from the University of Nebraska-Lincoln. We're 4 mechanical engineering seniors. It was really inspiring not just to see a lot of people who are working just as hard as we are, but also coming up with some really creative ideas.
Akita Prefecture University team. It is shortened to Akita team. The challenge gives us very unique environment and challenge, and our spirits are purified by the challenge. It's very honor for us for the chance for such precious time, and very thanks to the Airbus staff. Thank you.
This is Team Vayu. Vayu in Hindi means air, and we have named our team that because we are all aerospace students. What the robot basically works on is a 3-axis independent motion. We wanted to make it simple. We wanted to remove any circular motion or rotation, so we don't have to waste our time in fixing angles. This competition means so much to us as aerospace students, because as aerospace students we are making a change in the aerospace industry through this competition.
We all study together at a grad school called Nara Institute of Science and Technology. Well, the overarching idea of our robot is flexibility over rigidity. The idea that we can use the robot's own motors and force rather than its stiffness, its heavy structure, to ensure precision while drilling. What we decided to do is we designed an end effector with 3 points of contact which come down on the plate. They attach to the workpiece, so to say. Then the robot presses down on it, it pushes on the end effector, and that's what gives the drill its stability. I think what means the most to us in this competition is the challenge and the opportunities it brings.
We're R3. So we're a robotics collective from Ryerson University in Toronto, Canada. Our robot is pretty simple. We have 3 drills that are geared together on 7 drill bits, so that we can drill 7 drill bits that are constrained and just do the whole pattern basically 7 times as fast as anyone else. Being in this competition means a lot to us. We put in a lot of work, a lot of effort, so to see it come to fruition and be able to compete against teams from around the world, it really is excellent.
We are from NTU, Singapore. Basically, we didn't build anything. We just bought that and assembled, and then we do the programming. Basically, using this 3D camera, we're going to try to locate the reference holes. From the reference holes, we get the panel position and orientation in space. After that, we have a motion planning algorithm to plan the motion of the robot to move to the drilling position, and then we just drill. Now, with this very practical challenge, we have to put all our theoretical knowledge into practice. I mean, independently of the result we're going to have, the fact that we have worked really hard to put our ideas into practice, I think that's the most meaningful for us.
So hello everyone, I'm David Busson from Team Cirado, France. The robot is an LBR EWA, so it's the latest born of KUKA. So the end effector includes a drilling bit, a camera and a laser to relocate the end effector in regard to its environment, and lubrication system that helps with the drilling, as well as blowing to blow the bits of aluminium during the drilling process. So we were very proud to be accepted for the selections, and very happy to be here. Finally be here. We achieved a bit of hard work to come here because we developed it in quite a small amount of time. But I think this is the case for everyone here.
The rules of the competition are guys have to drill holes, maximum quantity of holes in 1 hour and at the right position and with the good quality. So the robot needs to be less than 100 kilograms, so lightweight for us, and then easy to integrate into production afterwards. It has to be modular, so it means that there are parts of the robots that are interchangeable from an hardware standpoint, but also from a software standpoint, and it has to be low cost also. So if the hole diameter is correct, they got 2 points. If the hole position is correct, they got 3 more points. And they can also have negative points in case of the hole is badly positioned. Also, they get 0 points if the hole is not drilled, obviously. And we are also counting the quantity of holes drilled by the team. So the quicker they are, the better it is. And we also have some difficult access area, constrained areas, where if they are able to drill holes in those areas, they are getting a large amount of points. I would like to say that all the teams involved were really deeply involved. And it was a great pleasure to me to have all those young guys full of energy and working on their stuff like crazy people, and it was really fun. So I really appreciate that, and I think it was also a very good opportunity for them to share together, to learn from each other, which is amazing to me.
And stop. Thank you very much.
Team Cirato from France. Second place, Cree Group from Singapore.